So, hi guys, I hope you are all doing well. So, today we'll be starting with our new chapter of class 9 mathematics, that is chapter number 5. In the last video, we have seen our chapter 4, that was exploring algebraic identities. I hope um you have gone through the chapter and you have solved the numericals and you have practiced well. So today we'll be starting with the chapter 5, that is I am up and down and round and down. I have noticed one thing in your new textbooks that they have given some uh, light lightweight names to the chapters so that it becomes comfortable for you as well to learn the chapters and to go through them. So yeah, the name suggests that the chapter is based on circles. So to start with the chapter, we can assume it as what does circle mean? So any circular pattern, or like, this is not a proper definition of circle, but you have learned from from your childhood that what are circles, what are circular patterns, how do you separate out the shapes, like we have square, we have rectangle, but you can find that key, oh, this is a circle. So humanity has always been fascinated by the shapes of the things around them. In some early cave paintings, the sun is depicted as a circle. In the cave paintings of Gudahandi in Odisha, one sees numerous geometric patterns, including triangles, squares, circles, and ovals. So many things are depicted by a circle. Like we have claw, we have a fan. Yeah, I think this is clear that what are circles. But now we can see raindrops also as a circle. We can assume them as circles. But we also in smaller classes you may have learned that Earth is circle. Earth is not circle; it is geoid in shape. But yeah, you can assume it as a circle because it follows a circular pattern, and from distance it seems to be a circle. But everything, a circle is a very logical. Like when we use circle, we mean something that is a proper shape and not anything that follows a circular pattern, because raindrops, for example, this log, as you can see in the picture, this log is follows a circular pattern. But if we have to state it mathematically, we cannot say it as a circle because of many certain reasons. Firstly, we'll need to understand what patterns do we call circle and what are all that patterns. So we shall study some of the definitions of a circle. Okay. So the very basic definition of a circle is a circle is the set of all points on the plane that are equidistant from a given point on that plane. I hope you are understanding what I am saying. Let's say that let me just open my whiteboard. Yeah, I'll just zoom it in 100%. Right. So let's say we have a point. Let's say we have a point, right? Okay, cool. So we have a point. Then what is a circle? A circle is a set of all points on the plane that are equidistant from a given point on that plane. So let's say this black part of my board is a plane. Okay, we have taken one point. All the points that are equidistant from this particular point. Let's say uh, I have a point over here. Okay. So I'll just make a set of all points. Okay. I'll take this point, this point, this point, this point, this point. Maybe this. Okay. If I join all the points and see, for your understanding, I have taken this many points, but there are infinite number of points lying on this circle. They are here also, they have points. Okay. So you may notice that all the points are equidistant from the given center point that is depicted by the blue color. So I hope this is clear that a circle is a set of all points that are equidistant, that is equidistant from a given point, that are equidistant from a given point on that plane. So for here, for instance, let's say we have A. So all the points over here, including B, C, D, E, and lying on this particular line is a makes a circle. Okay. I hope this is. इधर किधर है? हाँ. I hope this is clear. Okay. Also, next definition we have what is the locus. The set of points that satisfy given condition is also called the locus. So basically, locus is also known as collection of points. So basically, the set that we have called that is equidistant from point A is a locus. So we can also say that using this term, a circle can also be described as the locus of points that are equidistant from a given point. Locus can be depicted as the set of all points, basically collection of all the points. ठीक है, यहाँ पे infinite on this particular part, infinite number of uh, points lie. Okay, I hope this is clear. ठीक है, cool. Okay, so next definition we have center. So now we have seen that all these points, that the locus of point is equidistant from a given particular point. So this point is called a center. So for this circle, our center is point A. So basically a center of a circle is the point from where the locus of all the points locus of all the points are equidistant so that they form a circle. ठीक है? I hope this is clear. ठीक है. Next up, we have the definition of radius. Then what is a radius? So basically, if we take any point on the center of the circle, ठीक है? If we take any point on a circle, let's say point ये point ले लिया, ठीक है? Okay. If we join the point and the center of the circle, this forms our radius, that is denoted by small r. ठीक है? One more property of radius is if you take any point, I can take this point, this point, this point, this point, this point, this point. कौन सा भी point ले लो circle पे, the radius is always fixed because all the points on the circle are equidistant. No, all the points that lie on a all the points all the points are equidistant from the center. So basically, the radius is equal. So you take any point on the circle, it will be always they will be always 2 points will be always equidistant from the center, and they makes the radius of the circle. I hope this is clear. Cool. Next up, we have chord. If we take any 2 points on the circle, let's say we have taken point B and point C. So point B and point C, if we join the points, then the line formed by them is called a chord. Okay. You must notice that no center is involved in making of the chord, but may in further cases we'll be including the center also. So any 2 points lying on a circle, if we join them, they form a chord, right? Let's say B and C. Okay. Now, if we join 2 points that are if we join 2 points that lie on the center, let's say E and D, and that line passes through the center. This is also called because it joins the 2 points on the circle, right? And it passes through the center of the circle. Then this chord is called as the diameter of the circle, that is denoted by small d. You can say that अभी E और D ही क्यों, यहाँ पे कोई और पढ़ लेते हैं, ठीक है, ले लो. If we take this point that is P, if we say Q, if this passes through the center, then this is also a chord, and this can be interpreted as diameter only. So that is not a problem. Okay. So let B and C be 2 points on the circle. The line segment BC is called the chord of the circle. Okay. A chord passing through the center of a circle is called the diameter. I hope this is clear, and this all small easy peasy definitions are also clear. Okay. So if these definitions are not clear, you can go again and watch the video. Okay, cool. I hope this is clear. ठीक है. Next is symmetries of circle. So basically you can see that circle follows a symmetry. हर point equal है. ऐसा कुछ नहीं है कि अभी I have I am not able to make a proper circle. That is okay. But oh, we can make a circle as well here. Right. So this is not a circle. Sorry. This is a circle. We just try to. ठीक है. That is okay. We'll learn through the PDF only. ठीक है. So circle follows a symmetry that we can say that circle has a complete rotational symmetry. Everything is in symmetry. हर point equidistant है तो ये symmetrical है तो what is symmetrical? Basically, draw a line, if I draw a line and intersect it. So अगर ये दोनों parts equal है, so ये follow line symmetrical है, right? So I hope this is clear. One more thing that all the diameters are lines of reflection symmetry. ठीक है? Yeah. How many circles? So basically, this is the part to prove. We'll directly jump on the theorems and we'll not learn the proofs in this lecture. That is the self-study part, and that you all need to do it on your own. We'll just discuss the theorems. I'll just tell you what are the theorems, their meanings, their proofs. You need to derive it, and proofs are all given in the textbook. You just need to go through them, understand the concept, understand the proof, so you can directly uh, later you can derive the proofs on your own. Okay? I hope this is clear. One term we need to understand is what is collinear. Basically, if certain points lie on a same line, so basically I have 3 points A, B, C. If they lie on the same line, then they are said to be collinear. If I have 2 points over here, ये एक line पे है, but ये triangle बन रहा है इन तीनों से. So the no, points A, B, C are not collinear. But the if the points are on the same fall on the same line segment, then they are said to be collinear. Okay, I hope that is clear. Okay, let's get on our first theorem. Our first theorem states that there is a unique circle passing through three non-collinear points. Okay, ठीक है. इसका proof है that you need to do it on your own. Okay. What does it? Theorem one states that there is always a unique circle passing through three non-collinear points. You must focus on the word non-collinear that suggests that the three lines are not the 3 points do not fall on the same line segment. It may happen that 2 points lie on the same segment, let's say B and C, but A point is different. So maybe they form a rectangle or something like that. I mean, triangle or something like that. So if there are three non-collinear points, then there is always a unique circle passing through them. एक ही circle बनेगा, only one circle will be formed that passes through all the points. We have A, point B, and point C. You can see that only one circle passes through them. That would be of a fixed radius. That is not a thing to that we are not concerned with. But there is only one circle that will pass through the whole that will pass through all the points that are non-collinear. I hope that is understood. So you can see that they also form a triangle. Basically, like a 3 points, and if they are on the same circle, they will definitely form a triangle. It may happen that they are all SRB points over that. Okay. Okay. Next, we have few terms. The center of the circle that passes through the vertices A, B, and C of triangle ABC is called the circumcenter. So basically, for this type of circle, we have a circumcenter, and the circle is called a circumcircle, and the circle जो ऐसे इससे बनता है that is called a circumcircle, and the triangle inscribed and we said that the triangle is circumscribed in the circle, that is said to circumscribe the triangle. Basically, the circumscribes the triangle. Yeah, cool. uh, I think that is understood, and we can move further on our then next up we have exercise that you need to solve it on your own. Moving further, we have chords and angles de subtend. Let's get on our theorem 2. Theorem 2 states that equal chords of circle subtend equal angles at the center. So basically, you have seen that what is a chord. If we have a circle and we have joined 2 points, let's say A and B, and we have one more chord that is C and D, and this is our center O. So, what does the theorem 2 mean? It states that equal chords of circles subtend equal angles at the center. So, if I say the distance of point A to B that is equal to the distance of point C to D, that means if both the chords are equal, then we can say that they subtend equal angles at the center. So basically, if I join these points, okay, if I join this and I'll also join this. So basically, जो ये angle बना, that is angle COD and angle AOB, they are equal. In which case, if both the chords are equal in nature, then the angles that they subtend to that they subtend at the center are equal. Okay, I hope this is clear. You can see that the angle ACB and angle DCE are equal. When if the chords AB and chord DE of are equal. Okay, cool, understood? Yes. Next up, we have theorem 3. That is the converse of the theorem 2. As theorem 2 states that if two chords are equal and they subtend, if two chords are equal, then they subtend equal angle at the center of the circle. Now, the theorem 3 states that chords of a circle that subtend equal angles at the center are equal. Chords of a circle that subtend equal angles at the center are equal. So basically, if they subtend equal angles, if angle ACB and angle DCE are equal, then the chords are equal. That is AB and ED. If these both angles are equal, then these two chords are equal in nature. I hope this is clear. Uh, Cool. So next up we have exercise 5.2 that you can solve it on your own. Moving further, we have midpoints and perpendicular bisectors of chords. Now, what does our theorem 4 states? State the line joining the center of a circle and the midpoint of the chord of a circle is perpendicular to the chord. I'll read it again. The line joining the center of the circle and the midpoint of a chord. So we have a chord AB, we have a center C. So the line joining the center of the chord. AM, that means AM is equal to BM. If the line joining the center of the chord, the center of a circle and the midpoint of the chord is perpendicular to the chord. So it states that angle CMB and angle CMA is equal to 90 degree. That is perpendicular bisector basically. So I hope this is clear that if the line joining the center and the midpoint of the chord AB is perpendicular to the chord. That is, this is 90 degree. I hope this is clear. Cool. Next up, we have exercise 5.3. Again, you need to solve it on your own. Okay. We have theorem 5, that is the perpendicular from the center of a circle to a chord of the circle bisects the chord. So basically, it is again the converse of the first of theorem 4. It states that the perpendicular from the center of the circle to the chord bisects the chord. So basically, it falls to the center of the chord. So it bisects the chord that becomes AM and B. AM is equal to BM. I hope this is clear. We'll move further to our next topic, that is distance of the chords from the center. Okay, cool. We have theorem 6, that is chords of a circle having the same length are all at the same distance from the center of the circle. I'll repeat it again. Chords of a circle having the same length. One circle we have chords of same length, that is AB equal to GF. Okay. chords of a circle having the same length are all at the same distance from the center of the circle. So therefore, we can say that if we connect a line from the center of the circle to the midpoint of the both the chords, then we can see that if the chords are of equal length, then their perpendicular bisector would be also equal. So basically, this theorem states that C is equal to CH. So if both the chords of a circle are have same length, then they are at the same distance from the center. The distance of the center means that this is the shortest distance from the center to the line to the chord, because it makes a 90-degree. Okay, it makes a perpendicular. I hope this is clear. Okay. Moving further, we have exercise 5.4. I think this is a very big chapter because it has many theorems, but that's okay. You just need to understand the concept. Once you just go through the concept and you have understood the concept, then easily you can derive the proofs, and also you can recall the theorems. Theorem 7, chords of a circle that are equidistant from the center have equivalence. Again, theorem 7 is converse of the theorem 6, that if the chords of a circle that are equidistant from the center, it states that if the chords of a circle are equidistant from the center, then the chords are equal. Firstly, it was stating that if the chords are equal, then they are equidistant from the center. And next we have, if the chords are equidistant from the center, then they are equal in nature, right? Cool. Okay. Next up we have theorem 8. Let's say we have two chords, that is AB and DE. We have AB and DE with center C. Suppose AB is greater than DE, then the distance from C to AB is less than the distance from C to DE. That is obvious because the length of AB is greater than length of DE, so it is nearer to the center. So the distance from the center to the chord is of chord AB is larger than that of chord DE. So therefore we can say that CF, sorry, that then the distance is less than the that of chord of D. So you can say that CF is less than CG. It can be proved by using the Pythagoras theorem. So you can easily read it from the textbook and you can understand it on your own. Okay. Next up, we have angle subtended by an arc. What is an arc? Uh, okay. Let's say we have a circle. Uh, Here on the circle, we have 2 points. Let's say point A and point B. And this is the center O. And let's say, okay, so basically an arc is a connected portion of the circle that connects two endpoints, 2 points on the circle called endpoints. So basically we have seen that if we connect point A and B using a line segment, then it becomes a chord. If we connect both the points on the circle through uh, through a through the portion of a circle, then it becomes an arc. So basically, the part of the circle that is denoted by red color is called an arc of the circle. We can again join the arc to the center of the circle. You can also see that this part of the circle that is denoted by the green color, this part of the circle is also denoted by A, and that also connects the point A and B through the circle only. This is also called an arc, but the difference is as this is a bigger arc and it makes a bigger angle with center, so it is called a major arc, and the one with the red color is a minor arc. We do not need to go into major and minor arc. You just need to focus on arc. Arc is basically the portion of a circle that connects 2 points of the 2 points on the same circle, and these 2 points are called endpoints. So basically, point A and point B are called the endpoints of the arc. Okay, cool. Okay. Now you can see. Now we need to learn that what is the angle subtended by the arc. So basically, if we join, now you can see that this is an arc. Okay. So if we connect the endpoints of the arc with the center, we can see that we have formed an angle. So this angle is called as the angle subtended by the arc. ठीक है. It has also properties that we'll learn in the next few theorems. ठीक है. अब चलो आ ही गया. Angle subtended by an arc at a point on the circle outside the circle. ठीक है. We have theorem 9, that is the angle subtended by an arc at the center of a circle is double the angle subtended by the arc at any point on the circle outside the arc. ठीक है. So basically, let's say if this is our angle theta, and let's say this is our angle phi. So this theorem states that theta to theta is equal to phi. Right? It states that angle BCA is equal to, sorry, my bad. It states that angle BCA is equal to 2 angle BDA. So the theorem says that any point if we the angle subtended by the by an arc at the center of the circle. So ये this is our arc, ठीक है, and this is a angle subtended by the arc at the center. So it will be always double the angle subtended by the arc at any point on the circle outside the arc. So if I take this point as well, so let's say if we connect this point, let's say it is point F. So if we connect this point, then this angle, that is angle AFB. AFB again would be half of the angle that is connected, that is subtended at the center. I hope you have got a clear idea. And on theorem 9, I'll just repeat it and quickly summarize it. It states that the angle subtended by an arc at the center of the circle is double the angle subtended by the arc at any point on the circle outside the arc. It could be anywhere over here until it is outside of the circle. So ये यहाँ भी हो सकता है, यहाँ भी हो सकता है. It could be here also, it could be here also, it could be anywhere, but it should lie on the circle and outside the arc, not over here. This part is a red zone for that particular point. I hope this is understood. ठीक है, cool. Next up, we have a corollary. What does corollary mean? Corollary is a fact that follows immediately from an already proved result. ठीक है. The angle subtended by a diameter at any point on the circle is 90 degrees. What is a diameter? Diameter is the longest chord. Two endpoints passing through the center. So the angle subtended by a diameter at any point on the circle is 90 degree. If we connect any point, if we have taken this point also, it could have uh, it would have been 90 degree only. So it is always perpendicular. So it subtends 90 degree at any point on the circle. That is our theorem 9. Next up we have exercise 5.6. Again, you need to solve it on your own. Moving further, we have theorem 10 that lies under the concept of concyclicity of points. Okay. We call the points that are on the same circle concyclic. Okay, I hope this is clear. Theorem 10. If a line segment AB joining two points AB subtends equal angle at two other points CD that lie on the same side of AB, then the 4 points lie in a circle. Ooh, samjhani. Wait. Hold on. If a line segment AB, we have a line segment AB, okay? If a line segment AB joining two points AB subtends equal angles at other 2 points CD. So basically, this angle and this angle this angle is equal. Then C and D lie on the same side of AB. Also, the C and D lie on the same side. You can see that A lies on the same side of the C and B lies on the same side of the D. Then the 4 points lie in the same circle of the circle. So basically, we need to prove that all these points A, B, C, D lie on the same circle. And what are the conditions for it? If the line segment AB, if we join the points by line segment AB, and point C and point D lies on the same side of point A and point B, if we connect ACB and ABD, then if the angle ACB is equal to angle ADB, then all the 4 points lie on the same circle. This is theorem 10. It might sound thoda difficult, but you just read it, you just go through the proof, read it twice, you will definitely understand the concept, and it is very easy to understand. Basically, three things we need to understand that AB lie on the circle. We connect them through a line segment. C and D should lie on the same side as A and B respectively, and the angle formed by ACB and BDA should be equal. If this is the case, then A, B, C, D, all the points lie on the same circle. I hope this is clear. Okay. Now we need to understand what is quadrilateral. When the vertices of quadrilateral, which is also foregone or concyclic, then the quadrilateral is a cyclic quadrilateral. Basically, we know that quadrilateral is something is a closed figure formed using 4 points. So basically, if all the four vertices are concyclic, what does concyclic mean? That they lie on the same circle. Then the quadrilateral is called as a as a cyclic quadrilateral. Basically, we can see that the quadrilateral is circumscribed into the circle, right? So A, B, C, D, all the 4 points lie on the same circle, that they are concyclic. So if we connect them using a line segment, all the 4 points are connected, then it forms a cyclic quadrilateral. Okay, so what is theorem 11? The sum of two opposite angles of a cyclic quadrilateral is 180 degree. If you take angle A and angle C, then angle A plus angle C is equal to 180 degree. I hope this is clear. If we take angle B, angle D, then angle B plus angle D is also equal to 180 degree. So basically, all summation of all the angles make it 360 is equal to 360 degree, right? Because 360 degree is made by a circle also, right? Cool. Next up, we have theorem 12. That is, if two opposite angles of a quadrilateral add up to 180 degree, then the vertices of the quadrilateral lie on a circle. They are concyclic. Okay, theorem 12 is again the converse of theorem 11. If two opposite angles, if we say two opposite angles, angle A and angle B, angle D and angle B, if they add up to 180 degree, then the vertices of the quadrilateral lie on the same circle. So basically, it is ulta of theorem 11. I hope this is clear. We have covered all the 12 theorems that were very like the theorems were a bit lengthy, and also as it those are new to you, it might sound thoda difficult, but that's okay. With practice and with revision, you will get through them easily, and you will definitely understand all the concepts easily. That wouldn't be a problem. And I think we are done with this chapter. We'll just quickly summarize what all we have learned. We have learned that a circle is a set of all points in a plane that lie at a given distance from a fixed point called its center. Then a circle has a reflection symmetry across any diameter. A circle has a rotational symmetry about its center through any angle. Infinitely many circles can be drawn through two given points, but for three non-collinear points, there always exists only a unique circle. Right. Then further, they have just summarized all the theorems. I request you to go through the textbook once, read all the proofs, read it twice, thrice, as many times you want, until you understand them, and just do not rectify the the theorems. They do not just mug up the theorems and the statements of the theorems. You understand the concept behind the theorems, then it will be definitely easy for you to understand them and to practice them and to implement them in your exams, in your exercises and in the solved examples. Okay, then cool. I think we are done with this chapter. Go through the chapter once, twice, thrice, how many times as you want, until you get the concept, and do not mug up things. This is mathematics. Mathematics cannot be understood by just mugging up. Okay, you need to understand the concepts, and you need to revise the concepts again and again, and you need to implement them. Mathematics is a practical subject and not a theoretical. You need to solve and write it on the book. You need to practice them. ठीक है? I think we are done with this chapter. This is from my side. See you guys in the next video. Thank you so much for watching this video. If you have any comment, if you have any suggestions, feedbacks, doubts, you can put it in the comment section. I would like to I would definitely clarify them. Thank you so much for watching this video. See you in the next video. Take care. Bye bye. Have a good day.
वीडियोस बनाने हैं, फिल्मोरा है ना।